Okay, in our last class, we talked about dividing a polynomial by a polynomial. Okay, we use two methods. One synthetic division and the other one is long division. Okay, and those who were not here, please just go to the link and click the use the video. Okay, and we'll also doing the long division and synthetic division here as well. Okay, and one more thing, so we can always write, okay, just let me rewrite. So if we have a polynomial function, so let's say we have a polynomial function p of x. Okay, so let's say we have polynomial function p of x, and if you divide this polynomial p of x by the divisor d of x, okay, we can always write our polynomial p of x as a divisor d of x times the quotient. We write q of x for the quotient plus remainder r of x. Okay, so if you are dividing any polynomial by the other polynomial, you can always write your polynomial as a divisor time quotient plus the remainder. Okay, all right, now let's go ahead and do the next topic here. And next here we have the remainder theorem. So we have this remainder theorem, and this theorem help us to find the remainder. Okay, so we have a polynomial p of x and we have a divisor. So we using the remainder theorem, we can find the remainder without using the synthetic division and a long division. Okay, so if you are asked to find the remainder, you can always use a long division, you can always use synthetic division, and also we can also use this remainder theorem to find the remainder. Okay, now what it tells us here is that, so we have a polynomial p of x, okay, and we are dividing this polynomial by x minus c. So what is this x minus c? This is our divisor, right? So if our divisor d of x is x minus c form, okay, so you have any polynomial, it doesn't matter what polynomial you have, and if you are dividing this polynomial by your divisor x minus c, c is any number, then the remainder is always equals to polynomial at c. It means you substitute c for every x and you get the remainder here. Okay, so here we have an example. So we have this polynomial, okay, and we need to find the remainder p of t. Now it does tell here to use the synthetic division. Before this, let me solve this using our remainder theorem. Okay, so let me add one more example. Okay, let me cross this for a while. So we have this polynomial and we are asked to okay, let p of x is divided, let me add this, by x minus 2, find the remainder. Okay, so this is the question for it. Just let me correct here. So we have this polynomial p of x and we are dividing this polynomial by x minus 2 and we are asked to find the remainder here. So one way, you can use long division, you can also use synthetic division, but according to remainder theorem, okay, we can't use remainder theorem everywhere. Okay, there is a condition. Your divisor has two of this form, x minus c form. Your divisor has two of this form. Now is our divisor x minus 2 is same as x minus c? Are they in a same form? Okay, so let's compare. We can find by comparison. So our divisor is x minus 2. Let's compare x minus 2 with x minus c. If we compare here, for x we have x, for negative we have negative, and for c we have 2. So our c is 2. From this comparison we know what is c. Okay, now you substitute 2 for every x in your polynomial. So we substitute 2 for every x. So p of 2 equals negative 2 times 2 to the power 4 plus 6 times 2 cube plus 3 times 2 minus 1. So once you know your c, you substitute c equals to 2 for every x in your polynomial. See, for every x we substitute 2, and this gives us the remainder. when we divide this polynomial function by x minus 2. Now let's go ahead and simplify. So we have now this negative. So this negative is for 2, okay? So we have negative 2 as it is. And fourth power is only for 2. So fourth power of 2 is 16 plus 6 times 2 cube is 8 plus 3 times 2 is 6 minus 1. So negative 2 times 16 is negative 32 plus 6 times 8 is 48 plus 6 minus 1. Okay, negative 32 plus 48, that is, so we have 8 is 16. So we have a 16 plus 6 minus 1, that is 5, and we have 21. And this 21 is the remainder that we get when we divide this p of x by x minus 2. Okay, you substitute your c equals to 2 for every x, and that gives us the remainder. And this is our remainder theorem. And we only use this theorem when our divisor is of this form, x minus c form. Our divisor has to be of this form, x minus c form. If the divisor is not x minus c form, then you are not using this theorem. You need to use the long division. You can't even use the synthetic division. Okay, so this is how we can find the remainder. And if you want to use the long division, you know how to get the remainder, right? And you can also use the synthetic division here. Okay, this is our remainder theorem. So one more time, you have any polynomial, okay, and you divide your polynomial by x minus c. C is any number divisor. Then the remainder is always equals to p of c. It means you substitute your c for every x on your polynomial, and p of c is the remainder. Now the next theorem, we have a factor theorem, and factor theorem give us the factor for a polynomial. So we have a polynomial, and using a factor theorem we can always find the factor for that given polynomial. Now, so we have here x minus c, okay, c is any number. This x minus c is a factor of a polynomial if p of c is equals to 0. Now what is this p of c? What is this p of c according to our remainder theorem? P of c is the remainder, right? So if we go back here, see, so when we divide p of x by x minus c, the remainder is p of c. And when the remainder is 0, our divisor and quotient is always the factor, right? That's what it tells here. So we have x minus c. This is a factor for the polynomial if the remainder is 0. Okay. Now here, so we have an example. So we have this polynomial, and we need to check whether x plus 3 is a factor or not. Okay. Now there is a different method. You can use long division. So you can divide this polynomial by this divisor. If you get the remainder 0, then x plus 3 is a factor. The other way is you can use the synthetic division. You can divide this polynomial by x plus 3, use the synthetic division, and if you get remainder equals to 0, then x plus 3 is the factor. Okay, now using our factor theorem, okay, what can we do is that we can compare this x plus 3 with x minus c. So let's compare x plus 3 with x minus c. Okay, now we can rewrite x plus 3 as a x, negative, negative 3. Now if we compare, for x we have x, for negative we have negative, and for c we have negative 3. So from here our c is equals to negative 3. Now let's find the remainder. Okay, you can use long division, synthetic division, but we're gonna use our remainder theorem. So what do we do to find the remainder? You substitute negative 3 for every x in this polynomial. Okay, so just let me write p for polynomial at negative 3 is, you replace every x by negative 3. So we have 2 times negative 3 cube plus 3 times negative 3 negative 2. So this is 2 times cube of negative 3 is negative 27 plus 3 times negative 3 is negative 9, negative 2. So 2 times negative 27 is negative 54. So we have negative 11 and this is negative 65. Now this is our remainder, and remainder is not equals to 0. If the remainder is not equals to 0, our divisor is a factor or not? Our divisor is not a factor. So x plus 3 is not a factor. X plus 3 is not a factor. So to be a factor, your divisor can be a factor only when you get the remainder equals to 0. Okay, you find the remainder. You can use any method. You can use long division, you can use synthetic division, or you can use remainder theorem to find the remainder. And if that remainder is equals to 0, then your divisor is a factor. If the remainder is not equals to 0, then your divisor is not a factor. Okay. Now from here we can also, now if we can find what is C. Now if we, so from this theorem, if we know a C, okay, if we know a C that makes our function equals to 0, then we can find the factor of a polynomial by writing in a x minus C. Okay, so x minus C is a, will be a factor. Now here, so let me go back. Okay, we don't have a 0 here. So for example, so let me, so if we have a p of x as a polynomial, if p of 2 is equals to 0, so what do we call this 2? Can you recall? So we have any polynomial, okay, and when you substitute 2 for every x, if we get p of 2 equals to 0, what is that 2 is called? 2 is the, so you have a polynomial function, just let me write, you have a polynomial function p of x, okay, and you substitute 2 for every x for the function, and your output is a 0. And what if that is the case, what do we call our input to here? 2 is the, is that x intercept or not? So you see, you input your 2 for every x, and if you get the output 0, means your point is on the x-axis, that is the x-intercept, right? And is that a real 0 or not? So real 0 is a x, which give us our output is equals to 0. So this 2 is a real 0 or a x-intercept. Okay, so if you know a real 0 for any function, then the factor for that polynomial is always x minus that real 0 2. So x minus 2 is a factor for this polynomial, and this is what we will do in our next section. Okay, okay, so this is okay, this is all for section 3.3. okay, so before we start new section, let me just do the long division and synthetic division one more time. Okay, so let me use long division and find and determine whether x plus 3 is a factor here or not. So we have 2x cubed plus 3x minus 2. So we have 2x cubed plus 3x minus 2, and we are dividing this polynomial by x plus 3. Okay, so we're using a long division, and before you start long division, your divisor and the dividend has to be in the descending order of exponent of the variable. Okay, so here this is the divisor, this is the dividend, all of these terms are in the descending order of the exponent. Now how do we find the quotient? We take the leading term of the divisor, sorry, dividend. So this is the leading term of the dividend, and we divide this leading term by the leading term of the divisor. So we divide 2x cubed by x, and if we divide 2x cubed by x, we have 2x squared. This 2x squared is the first term of your quotient. Let's write down here 2x squared is the first term for the quotient. Okay, the next step, we multiply this first term of the quotient and every term of the divisor. So we are multiplying every term of the divisor by the quotient. So 2x squared times x is 2x cubed. Okay, 2x squared times positive 3 is positive 6x squared. The next step is we change the sign. We flip the sign of these terms here. So 2x cube is positive, so we use negative here. 6x square is positive, so we change into negative. And we will be using this new sign, okay? To simplify, we will be using these new signs. 2x cube positive minus 2x cube, this is 0, okay? Now 3x and negative 6x square, these are not a like term, so we can't add. So let's write these together. So let's drop negative 6x square, let's drop positive 3x and negative 2. So you drop every remaining terms. 3x and negative 6x square, these are unlike terms, so we have to drop every terms. Now we repeat the same process. We take the first term negative 6x square and divide by the first term x. So negative 6x square divided by x, this is negative 6x. So this is your next term of the quotient. So negative 6x is the second term. Now we multiply this second term and every term of the divisor. Negative 6x times x, negative 6x square, negative 6x times positive 3, that is negative 18x. We change sign, we flip the sign. So negative 6x square change into positive 6x square, negative 18x change into positive 18x, this is 0. Positive 3x, positive 18x, that is positive 21x. Now we drop the remaining term negative 2. Repeat the same process. You take the first term, divide by the first term. 21x divided by x is 21, positive 21. This is the next term of the quotient, positive 21. We use positive 21 to multiply each term of the divisor. Positive 21 times positive x, positive 21x. Positive 21 times positive 3, that is positive 63. So we change the sign. So positive 21x change into negative, positive 63 change into negative, this is 0. Negative 2, negative 63, that is negative 65. And whatever we have here is the remainder r of x. Is that what we had earlier, negative 65? Yes. See, this is the remainder here. Okay, so this is the long division. And what is this? This is our quotient, okay, q of x. This is our r of x. This is our divisor, d of x. And this is the dividend is our polynomial. And we can always write this polynomial, okay. You can always write your polynomial that is 2x cube. So you can always write your polynomial 2x cube plus 3x minus 2 equals to divisor, which is x plus 3, divisor time your quotient, which is 2x square minus 6x plus 21 plus remainder, which is negative 65. Okay, you can always write your polynomial. This is your polynomial equals to divisor times the quotient plus remainder. Okay, so this is our long division. Now for synthetic division, let me use the same here. So do you have any question here? Okay, now let's use the synthetic division. So we are dividing 2x cube plus 3x minus 2 by x plus 3. So we are dividing by x plus 3. So we're going to use synthetic division. And before we use the synthetic division, we must check our divisor is in the x minus c form or not. So if our divisor is x minus c form, then only we can use the synthetic division. We can't use synthetic division everywhere. There is a condition. Your divisor has to be of x minus c form. Okay, so once your divisor is x minus c form, you compare your divisor. Our divisor is x plus 3. You compare your divisor with x minus c. Okay, if we compare for x, we have x, and for c, we're going to have negative 3 here, because we can write this as a negative times negative 3. Okay, so from comparison, our c is negative 3. So you find what is c. Okay, now you write down the coefficient of each term of the dividend. So this is our dividend. We write down the coefficient of each term, okay, and make sure your dividend is in the descending order of exponent of the variable. So the coefficient of cube terms is 2, okay. After cube terms in the descending order, we should have a square term, and that is missing here. And if we have any missing term, we use 0 as the coefficient. Okay, after a square term, we have the x term whose coefficient is 3 and the constant is -2. And we divide this coefficient by our c, which is -3. If there is any missing term, you're going to use 0. Now let's drop. So for the synthetic division, you drop your first coefficient 2, and you multiply this dropped coefficient with this c. 2 times -3, that is -6. Okay, we are not changing sign, so 0 minus 6, that is -6. We repeat the process. So -6 times -3, that is positive 18. We are not changing sign. 3 is positive, 18 is positive, so we have 3 plus 18, 21. 21 times -3, that is -61. Sorry, -63. And -63, -2 is, that is -65. And whatever you have at the end, that is your always remainder r of x. Okay, and these numbers are the coefficient for the quotient. Our quotient is q of x, and to write the quotient, we need to know what is the degree of our dividend. The degree of dividend is 3. If the degree of dividend is 3, what will be our degree of quotient? It is always less by 1, so it has to be 2. So we're gonna have a x square term as a first term, leading term. So this is the coefficient of x square term, this is the coefficient of x term, and the remaining is constant. So we have 2x squared -6x plus 21. This is the quotient. Okay, so here we use long division, synthetic division, and a remainder theorem to check whether a given divisor is a factor or not. So you can use any method. If it does not specify, you can use any method, and the easiest would be using our remainder theorem. Okay, that would be easiest way to know whether the divisor is a factor or not. If you get the remainder 0, it is a factor. If you get not 0, then your divisor is not a factor. Okay, any question?